Hello, everyone. We're going to discuss this news that was published by the Department of Energy related to the Quantum Leadership Act of 2024. So, basically, they've published this new guidelines where they indicate where the different funds that have been allocated they should be used now in the different sections. This is very interesting because basically it's an increase of many $1 million. Like in 2018, it was thought to be around 750 million, and now it's been increased to $2.5 billion, which is a certain increase. This is a clear sign, right, that quantum is progressing faster than expected and basically is gaining attention from governments and entities. As mentioned in this Leadership Act, basically the quantum systems, they present a complex workforce, security, technology, and commercialization challenges, right? And we are still at a point where there is not yet a commercial advantage. We have many startups and bigger companies working on the development of quantum systems, but there are still many challenges towards bringing quantum systems actually into commercialization, right? So not only to be used in the lab settings, but actually used by enterprises, for performing their own, to be applied in their own daily tasks. Yeah, and so as you mentioned, actually it was not 2019, it was 2018. There was a previous act where around $700 million was allocated for this Department of Energy. But now in 2024, 2.5 billion have been allocated. Just a very good increase, to be able to fund all the necessary aspects for the continuing advancing with quantum computers. Also, as is mentioned, these funds are for 5 years, so from 2024 till 2029, and basically they will continue now to expand all the different activities funded by the Department of the Energy of the United States. And as they say, basically they will work with the 5 national research centers to study and address quantum supply chain challenges. For example, let's say in the case of IonQ, so depending on the materials that they're using, on the trapped ions, or if it's for superconductor computers, what materials are they using? What are the challenges are related to the supply chain? And basically to improve or to ease the commercialization of these systems. Then also to increase the integrity and industry coordination. That let's say we have the research entities, universities working closer with companies, and we have the startups which are basing or focusing on different technologies for building actually quantum computers. And so with this act, the idea is to coordinate much better in all these different organizations. It's also mentioned that this is very important, that they will establish new programs to support the workforce demands of the growing quantum research and development and commercial ecosystems. This basically, there's a big issue related to quantum, and it's the fact that we don't have the needed workforce from the point of view of, all right, we have researchers which are developing quantum computers based on different technologies. But once these systems have been developed in the next few years, then we need a big workforce of engineers, scientists, and in the end, users, which are able to make practical applications with these quantum computers. So you need to be able to program them and to know to which applications can you apply them. For example, in chemistry, in material science, for finding new properties, from materials which are strengther, cheaper, lighter. For chemistry, as I've mentioned, then for developing new specific compounds that can be used for new medicines, or also for quantum AI. So you need to develop all the machine learning algorithms now that can be then run or executed on quantum computers. So there are six different sections to this general release, this press release from the Department of Energy, and here they've been summarized. So section 1 is just the title, and section 2, it's the actual parts now of the science research program. So basically, it's to provide the Department of Energy quantum and research and development funds, which are in a total amount of 775 million over 5 years. And as I've already mentioned previously, 5 years ago or 6 years ago in 2018, it was actually 750 million for the 5 consecutive years. And currently, we are getting the same amount of funds, but per year, which is a very steep increase. Then it's also mentioned that it broadens the program scope beyond fundamental research to also include science, technology, engineering, development, and demonstration activities. So it's not anymore about researching if, let's say, quantum systems are able to be developed, no? But also, like, all right, once you have a quantum system, what can you do with it? What problems can you solve? Also, benchmarks. How can you compare this with classical computers? Where are the increases, right? Performance increases. Next topic is basically that the engagement with the private industry. It's very important here. It's mentioned especially for small and medium-sized businesses specializing in quantum technologies. So there are many startups, for example, IonQ, and they've been developing their quantum systems based on trapped ions already since 5-6 years ago. And currently they've been on a hiring spree. They've attracted very good talent from top companies such as Microsoft, Nvidia, and other companies. And basically, this shows that there's something that they're actually making good progress, right? As such engineers and scientists who have worked at top companies, that they decide to change the workplace to IonQ, to a small startup. And basically with these funds, then they want to especially work closer with small and medium-sized companies. Then the next thing that this program will support is to basically build or like to define a 10-year strategic quantum high-performance computing plan. So probably to define, all right, what technologies will we use? Because as quantum systems, they have many different technologies. Then which one is the best, or what combination of these technologies for building our quantum high-performance computing systems? Then specifically for supercomputing quantum computers, these funds will help establish testbeds and prototypes for building these systems, right? Then, as we mentioned, identifying quantum supply chain challenges and Most importantly, also, is to create a quantum traineeship program to address workforce development needs. There was a podcast some days ago from Physics World where Margaret Arakawa from IonQ, she was mentioning actually this problem with the actual ecosystem of related to the workforce. Now that you need the universities to actually start developing more programs related to quantum systems, that more graduates start coming out from university with the knowledge related to quantum systems that they can program and work with these systems once they're ready. Because it could happen that in 2 3 years we have quantum singularity or supremacy, where basically for specific problems, quantum systems are able to solve them much faster than classical computers, but we are lacking then the actual workforce, the actual scientists, engineers who can work with these computers and then develop the algorithms and the software needed for running this. So this is also a key aspect, right? Not only developing the quantum system, but also once you have it, right, do you have the actual workforce? Do the private companies in chemistry industry, in the machine learning industry, in the automotive industry, do they have the actual engineers there that can work with these systems and apply them to their own problems that they try to solve? The next section basically it defines the quantum instrumentation and foundry program, where 250 million have been authorized over 5 years for a new research and development, design and procurement program. Section 4, it's related to the National Quantum Information Science Research Centers, and $875 million have been authorized for the 5 Department of Energy quantum research centers in the US, and also it will encourage the coordination between these centers and the quantum education activities. Section number 5, it was discussed about the Quantum Network Infrastructure Research and Development Program, because also like once you have quantum computers, it's not only about actually the problems that you can solve with them specifically, but also is then it enables another, let's say, dimension for communications, right? Like then the internet could be a quantum internet, much safer, faster, and secure. So basically, in this 5th section, it was mentioned what this program will tackle, and it will expand upon the quantum network program authorized by the CHIPS Act, which has been developed now or defined during the last few years to promote in the US, basically, to invest in microchips and computation systems. And so as we mentioned, with this quantum network program, we want to support the build out of a quantum internet and quantum networking and communications research. It's in the future, 10, 15 years, maybe like the actual internet we're using nowadays will be enhanced to a quantum internet. I will probably do a video in the next days or weeks related to the quantum internet and basically what it is, what it will actually enable, and what are the pros and cons with regards to a normal internet that we're using currently nowadays. And finally, the last section was related to the quantum user expansion for science and technology program. Basically, it expands upon the QUEST program authorized by the CHIPS and Science Act, which works to establish public-private partnerships to provide greater access to quantum hardware and computing clouds. So again, basically, once quantum systems have been developed, we need the actual knowledge and structures that are related to the workforce, the companies, that are able to use these systems. So this is a very interesting act, and it's great that we see that in comparison to 5 years ago, the funding has been increased like 5 times fold. So not anymore. So it was 5 years ago 700 million, and now it's 2.5 billion, which is a very steep increase. That means also that at the US, at least at the Department of Energy, they see that quantum systems are coming, and it is not anymore like a dream or some crazy technology that it may or may not take place or happen, but actually with such increase in funds and specifically with the topics addressed, that not only for research and development of the actual systems, but make focusing on the actually ecosystem, the whole workforce, the knowledge basically, that they are basically acknowledging that right quantum systems will probably arrive in the next few years, but are we prepared to actually make use of them and to apply them to the problems that we would like to tackle? So yeah, this is great, and this is the first video of this channel, and basically I've been following all the news around quantum systems in some years, and now that things are getting spicy, I thought, right, let's create a new channel to focus on it. And specifically, I very much like the implementation of the technology that IonQ is working on. So we'll probably also focus on them for a while. And the next few years, as they progress towards a commercial advantage quantum computer, then I would like to continue recording some videos and discussing about these technologies and showing you all the progress and advances made. So thank you very much and have a nice day.